Well, hello calculus students and seekers of truth. In this video, we are going to study polar coordinates, polar functions. I hope that some of this, hopefully most of this, is review for you. But either way, we'll take our time and go at a nice and steady pace. Okay. So let's understand a little bit about polar coordinates, and I think it's helpful for us to contrast polar and rectangular coordinates. So what we learn here in the Cartesian coordinate planes is what's called rectangular coordinates. Okay? This is expressed in terms of x and y, right? So if I want to identify this particular point right here, then this is my x coordinate, this is my y coordinate, and the way that I would describe that is starting at the origin, going some direction left or right, and then going some direction up or down. Okay. Now polar coordinate takes a little different approach where we are still using the xy plane, but the way we describe this point is a little bit different. We use an order pair r and theta, where r is a directed distance, so positive r means that we are going to the right. So we're always starting at the origin. Positive r means that we are going to the right. Negative r means that we are going to the left. Okay. Theta is a directed angle. If theta is positive or theta is greater than 0, that means we are rotating counterclockwise. Okay. And if theta is negative, less than 0, then we are rotating clockwise. Okay. So for theta, it's kind of what we learned in the unit circle and how we rotate there. R here is a little bit different. In the unit circle, we're always starting on the positive x-axis. In polar coordinates, we can start on the left or the right of the y-axis of the y-axis. Okay? All right. So the way that we describe this ordered pair here in polar coordinates is we would travel out some length r, and then we would rotate some amount theta. And so rather than saying go to the right 3 and up 4, we would say go to the right 4.3 units and rotate pi over 6 radian. Okay? Or we could also go in the left direction and rotate this way. Okay? So what you see here is that polar coordinates are not unique. There are more than one way to identify a particular point using polar coordinates, while there are only one way, to describe something using rectangular coordinates. So I think it's best if we continue this study by looking at a few examples. Alright, so here we are asked to graph the following polar coordinates and then to convert them into rectangular coordinates. Okay. And the way that I've drawn this up, we're using graph paper, but polar coordinate graph papers are a little bit different. Instead of the grid that we're used to, we're going to use a series of concentric circles and then these radial lines here, that's what we're calling them. They start from the origin or the pole, okay, in polar coordinates, and they extend out from there. So the first point A means is 3 pi over 4, means we're going to go over to the right 3 units. Then we're going to rotate positive pi over 4. So for those of you who are still not on the radian mode yet, that's 45 degrees. So that's right here. So we're going to travel along this arc or this circle, pi over 4 units. And I'll just draw it in here. So this angle here is pi over 4, and this is where point A is located. For B, we're gonna go to -3 and pi over 6. So we're gonna go out to the left this time. We're gonna go out to the left 3 units, and then pi over 6 is positive pi. It's saying positive pi over 6. So remember, we're going to rotate counterclockwise. So starting here, we're going to go counterclockwise. Pi over 6 gets us down to here. Okay, so this is point B. And then the point C, we're going to go 4 -5 pi over 6. So we're going to go to the right this time because r is a positive number. We're going to go out here to this point, that's 4, and this time -5 pi over 6 because the angle is negative, we're going to rotate clockwise. We're going to go this way. 5 pi over 6, which it puts us, let me scroll down just a little bit here. 5 pi over 6 puts us past pi over 2 all the way out here. Okay, so that's where C is going to be. So point A, point B, point C. Let's see if I can trace this arc. All right. And so now this is how we identify these points. A is over here, B is over here, and C is over here. Notice that there's different ways that we can use to describe the same points. Again, polar coordinates are not unique, or in other words, a singular point. There are multiple different ways to describe it using polar coordinates. All right, now the question is also asking, just for good practice, let's convert this into rectangular coordinates. In other words, if I wanted to describe how do I reach this particular, let's say point A here, going in the X direction and then going in the Y direction, how would I describe that? Well, here we just use right triangle trigonometry, right? This radial line here, or this radius here, it's still 3. It hasn't changed. This angle here is pi over 4. So to calculate for A, right, its X coordinate is 3 times cosine of pi over 4. And the Y coordinate is 3 times sine of pi over 4. Okay, which gives us root 3 over 2 times 3, and root 2 over 2 times 3. I'll write it that, because cosine of pi over 4 is root 2 over 2, and sine of pi over 4 is root 2 over 2. And we're multiplying that by 3 because that's the radius here if you just use right triangle trigonometry. Okay. All right, how about point B? Well, there's, again, we want to figure out how do we get to point B going left, right, and how far do we go out this way? This would be the X, right? And how far we go this way, this would be the Y. And this is going to be a negative X and negative Y, and we know that this angle down here is 5 pi over 6. Okay. And 5 pi over 6, you can convert that using the reference triangle. That's the same thing as pi over 6, or a 30-degree angle, and then you can stick the negatives in the front there. But it's actually perfectly okay to use this trick. X is just nothing more than the radius, which is negative 3, times cosine of 5 pi over 6. Oh, I'm sorry, was it 5 pi over 6 or pi over 6? Oh, it was just pi over 6, excuse me. So let's correct that. This is cosine of pi over 6. And Y is negative 3 sine of pi over 6. Okay. So cosine of pi over 6 is root 3 over 2. So this coordinate here is negative 3 times root 3 over 2. And sine of pi over 6 is 1/2 times 3. So that's negative 3/2. Okay? So what I have written in blue here is the same thing, is another way to describe the same point, but using the old rectangular coordinate system. All right, now finally, same with C. We're going out 4 units, and then we're rotating 5 pi over 6 units. So for C, we can use the same idea. The X coordinate is 4 cosine of 5 pi over 6. And the Y coordinate is 4 sine of 5 pi over 6. So you got to know your unit circle well. 5 pi, the cosine of 5 pi over 6 is negative root 3 over 2. Okay. So this, maybe we should simplify this a little bit here. So X is equal 4 times negative root 3 over 2. And Y is equal to 4 times, now sine of 5 pi over 6 is 1/2. Okay. Now shoot, I'm sorry. I messed this up again. This one, the angles are supposed to be negative. Okay. So cosine of negative 5 pi over 6 is a negative number, and sine of negative 5 pi over 6 is a negative number, so it's negative 1/2. So when we put these numbers in here, it should still make sense. This is 4 times negative root 3 over 2, so that's just negative 2 root 3, and 4 times negative 1/2, well, that's just negative 2. Okay, I'm going to put this back here. So this is point C. Okay. So there we go. We've started off here learning a little bit, or maybe reviewing a little bit, about polar coordinates, and basically you should now know how to plot some points in polar mode. In the next videos, we are going to study how do we graph polar equations, and then how do we work with calculus using polar coordinates. As always, keep working hard. When you need help, ask. Thank you for watching, and have a wonderful day.